back today with exercise 8b, expanding perfect squares, and your favourite rule in maths, the difference of two squares. Now I know it says difference of perfect squares there. I'm going to get rid of that. Difference of two squares, because they don't need to be perfect, and we'll show you what I mean by that in a minute. What do they mean by perfect squares? Perfect squares are expressions which are squared raised to the power of 2. Probably doesn't look so good writing over that dark section. Write it a little bit lower. And at the moment we're mostly concerning ourselves with binomial terms. Expressions in brackets with just two terms in there. If I expanded that, well, a plus b squared is a plus b multiplied by itself, isn't it? And using our expansion rules, everything in the first bracket multiplies everything in the second bracket. We've got a times a squared, a times b is ab, b times a, I could write it as ba, but I'll write it as ab to keep the same alphabetical format, and b times b is b squared, and we end up with a squared plus 2ab plus b squared. And again, you can see that in your little box method if you wanted to. A plus b, a plus b, so this time they're the same length, it's a square, and we've got a squared. A times b is ab, a times b is ab, and b times b is b squared. And you can see we get the same answer. Now I want you to be able to go straight from a plus b all squared is the first thing squared plus 2 of the first thing times the second thing, because that happens twice, doesn't it? We saw that it happened twice. And then the last thing squared. If there's a minus sign in between, what's the difference there? Well, when I square a, I still get a squared. When I go a times negative b, I'm going to get negative ab, and then it's going to happen again in the next expansion, so it's going to be minus 2ab. And then negative b times negative b, two negatives multiplied together give us a positive. So that's what it looks like when there's a minus sign in between. A minus b all squared is a squared minus 2ab plus b squared. So they're perfect squares. They will always be in that form. Either the first one there or the one below it. Favourite rule in maths. Why is the difference of two squares your favourite rule in maths? Because it will save you more time than any other rule between now and when you finish school. So I think some of you might have had Mrs. Tucker. She would have been Miss Appleton back then in grade 7. She would have taught you favourite rule in maths, or favourite, was it the number line? I think it might have been. And adding positives and negatives together. We've moved on from that. When you grow up, you get a new best friend. New favourite rule. This time our favourite rule is the difference of two squares. Let's see why it works. If I have a plus b multiplied by a minus b, well, a times a is going to give me a squared. A times negative b, negative ab. Here I've got positive b times a, so that's positive ab. And then positive b by negative b, positive times a negative is a negative b squared. You can see those middle terms disappear, and I'm just left with a squared minus b squared. So it's a nice quick one. If you can recognise that pattern, a plus b, a minus b, you can go straight to your answer. We can also do it, as they point out here, it doesn't matter if it's a minus b times a plus b. Multiplication is commutative. We can do it in either order. That is the difference of two squares. Now again, they say perfect, but I'm just going to leave it as two squares. Let's have a go here and expand these. So when I'm expanding x minus 2 all squared, I tell myself it's the first thing squared. Minus 2 times the first term times the second term plus the second term squared. So that's x squared minus 4x plus 4. And that's all you have to do. If we have a look at b, 2x plus 3 all squared, well, that's going to be 2x all squared plus 2 times 2x times 3 plus 3 squared. 2x all squared, so 2 times 2 is going to give me 4, and x times x is x squared. Now the middle term, it's positive. 2 times 2 is 4, times 3 is 12, and there was an x there, so 12x. And then finally 3 squared is 9. All right, that's my turn. There are 2 there for you to try. I'll shrink it down a bit so you can still see the working there on your screen. Have a go at those 2, and then click unpause to see how you went. And there you have it. x squared minus 6x plus 9. And the second one, 3x when I square it becomes 9x squared. 2 times 3x times 4 is 6x times 4, 24x. And the 4 squared is 16. So writing that first line as I did in my example isn't necessary. If you're great at your multiplying and you think you've got your head around it, you can go straight to the answer on these. There is nothing wrong with that at all. Finally, difference of two squares. How do we cope with these? X plus 2 times x minus 2. Well, I think that's going to give me the first thing squared minus the second thing squared, which of course is x squared take 4. And again, I'm happy for you to go straight to that answer, x squared minus 4. So maybe I'll put that in little brackets there. It's an optional line of working. Second one here, 3x minus 2y, 3x plus 2y. So the first term is going to be 3x squared. What happens when I square 3x? I get 3 3s are 9, and x times x is x squared. 2 minus, and then 2y squared. 2 2s are 4, and I'm going to have y squared. And you can just do it that quickly. Easy marks for you in the exam. All right, again, a couple for you to try on the right over here. Maybe I can move it a little bit closer so we can keep you the examples there if you need them. Pause the video again and have a go at those two and come back and check your answers. And there you have it. First one, x plus 4 times x minus 4 is x squared minus 4 squared. 4 squared, of course, is 16. And the second one, if it's a 5x and I'm squaring it, you square the 5 and the x. So it becomes 25x squared minus, and then 3y times 3y is 9y squared. Now, I did say this is not just for perfect squares. I want to give you an example, and it probably comes up more when we're factorising, but if I have x squared minus 7, and I wanted to go the other way and use my difference of two squares to factorise that, I could think of x squared minus 7. 7 is not a perfect square, but I could think of it as the square root of 7 squared, which enables me to write it as x plus root 7, x minus root 7. And likewise, if I was expanding x plus root 7 times x minus root 7, x times x is x squared. That gives me my first term. And root 7 by root 7 is just 7. So x squared minus 7 would be the result of that. So just pointing out that it's not always for perfect squares only. It is for other numbers as well. All right, there you go. That's your video for exercise 8B. Catch you a little bit later. Bye for now.